Hello everyone, you're welcome back to another new episode from Source Arena Academy. In today's episode, we are going to be taking a look at pinhole camera. Don't forget that this is physics and everything we are doing here is in line with the syllabus that is given to us in JAM. So today, I'm going to be showing you how to answer questions on pinhole camera. What are the likely question in a well-explained manner? The question that normally asks you on pinhole camera will be reviewed to you today. As for those of you that are writing JAM, and if you are not writing JAM, you are in the right place because here will give you an insight knowledge on this type of camera. At the end of my video today, I'm going to be explaining to you how we can solve this problem that is on the board. Thank you so much. If you are new to my channel, don't forget to subscribe to my channel and also like my video, share the video with your friends. Thank you so much. Today, let's move on. Now, in my last video, we talked about light energy and I explained to you the propagation of white light, and I said to you that light can be propagated in a straight line. Today, one of the major applications of this has been given to us. Now, when we talk about a pinhole camera, the working principle, or let me say the actions of a pinhole camera, is dependent on the fact that light travels in a straight line. Are we together? That is one of the actions of a pinhole camera. It is using the fact that light is traveling in a straight line. Now, a pinhole camera is made from a light-proof box, which does not allow light to pass through it, except in the word pinhole. Now, it looks exactly like this. This is the box here. Now, it has a tiny hole here that allows the passage of light through it. Let me say, we have something here. If I have an object here, now this is the point here. Now, you see, this kind of mirror here has a screen at the back here, while the inner part is black. It is painted black. The screen is at the back here. Now, this hole here is the point in which light ray is going to enter into the material from this hole here. Light will pass through this hole into the material. Let me try to draw it very well. Now, light will pass through this tiny hole into the material to formulate an object in this place here. Now, let's continue. Now, you see, I'm going to be showing you some kind of things here. Now, what are the major things where questions will be asked from you under this? Number one, the kind of image that is formed by this object depends on what? We can have, as in the kind of image that this object can be used to what? To produce. All together, depends on the kind of object. We can have a moving object, and we can have a static object. Majorly, a pinhole camera is used to produce an image of a static object, not a moving object. I want you to take note of that. It is used to produce an image of a static object. For example, I just stand like this. Altogether, we can produce the image using a pinhole camera. And what is the major reason why a pinhole camera is only used to produce an image of a static object? It is because of the long exposure time. The image produced by a pinhole camera depends on the exposure time. Exposure time. Are you getting me? Because a pinhole camera will need to be set down, and it took longer period of time for the image of the object to be formed on the screen. Altogether, will be like that. So it took because of the long exposure time, it can only be used to take a static object, the image of a static object, not a moving object. Take note of that. This is quite important in JAM because I think I saw a question in JAM that is related to this. Before I move on, I think I have the question here. The question said, which of the following statements is or are correct? A pinhole camera cannot be used to take the photograph of a moving object because the pinhole is usually too small. The object has to be at a fixed point. The object has to be at a fixed distance from the object has to be at a fixed distance from the pinhole. That is sorry, let me take it from the ground. It said the pinhole is usually small. The object has to be at a fixed distance from the pinhole. A long exposure time is necessary. Altogether like that. Now, it cannot be used to take a photograph of a moving object because of a long exposure time. Are you getting me? So before the object will move, are you getting me? It might not even snap anything from the object. Why? Because the object might have moved, but you see, my normal camera is going to perform it perfectly. Our lens camera is going to perfect it perfectly, because a lens camera can be used to shoot both a static object and a moving object. Thank you so much. I'm sure that you're grabbing this so much. At the end, I'm going to be asking a question. Don't forget about that. Now let's continue. That is number one question that you'll be asked in JAM. The second thing that you need to know about this pinhole camera is what kind of image is formed. Are you getting me? Now, the nature of the image that will be formed, we'll talk about nature. The nature is referring to what? Is it forming a virtual image, or it is forming a real image? And in what way is the image going to be formed? Is it going to be an erect image or an inverted image? This is what we call nature of the image. Now, a pinhole camera can only form a real image. Are you getting me? Why is it real? The reason why the image is real is because the image is formed on the screen. Now, there are two different kinds of image that can be formed by an object. I guess we can have a real image and we can have a virtual image. A real image is an image that can be formed on a screen, that is formed directly on a screen, while a virtual image is an image that cannot be formed on the screen, but it is assumed to be there. But one thing is that you should know that all pinhole camera will always form an image which is real. And another thing I want you to note in this is that a real image is always collocated with an inverted. Simply means all real images are always inverted. They are always inverted. So our pinhole camera will form a real and inverted image. That means the image will be upside down as shown in the diagram. Look at the objects here. This is the image. The image is always upside down. That is one of the characteristics of the image form. Another thing that I want you to know is that the kind of image that is formed, what does it depend on? Now look up something here. You always ask question about this. The image might be a sharp image or a blur image. Blur simply means it's not sharp. Now we can have a pinhole camera might form a sharp image, or it can form a blur image. This type of this form of image that can be formed depends on the size of the O. Are you getting? Now, the smaller the size of the O, the sharper the image. When the O is a little bit larger, then more light rays tend to move into the O, which makes the image to be forming something that is blur. It forms a blur image. Simply means when the size of the pinhole is large, then the image tends to be blur. But when the size of the pinhole is small, are you getting me? It forms a sharper image all together like that. So that is one thing I want you to note. I think I got a question about that also. Okay, it said which of the following statements is or are correct? The sharpness of the image formed by a pinhole camera depends on I, the size of the pinhole, I, the distance of the object from the pinhole, I, the length of the camera. The answer to that is that the sharpness of the image that is formed only depends on the size of the pinhole. Please take note of this. The kind of image that can be photographed, either a moving object, the kind of object that can be photographed depends on the exposure time. Are you getting me? So because of the long exposure time, it can be used to photograph a static object, cannot be used to photograph a moving object. Thank you so much. Now, another thing I wanted to know is that I said the sharpness of the image that is formed only depends on the sharpness of the image that is formed only depends on the size of the pinhole. If the pinhole is smaller, the smaller the pinhole, the sharper the image. But when the pinhole is kind of large, now you guys understand, it formulates a kind of blur image. These are the two things I want you to grab when we're talking about pinhole camera. Now let's talk about something that is much important, is the calculation aspect of it. Question will be given to you on the calculation aspect, but majorly we want to know about the magnification of the image form. When we talk about magnification, as in enlargement of the image. If the image is the size of the image, the height of the image is 2 meters, then the image can be extended towards 4 meters. That's what we call magnification, enlargement of the image. All together. Now, let's take a look at it. Now, you see, another thing that many students does not know. Look at this place here, which is the surface of the camera. This is where the pinhole is found. Are you getting it? The distance from the pinhole to the screen here is known as image distance. We take it as the image distance. Let me take it out. Image distance. While the distance from the object to the surface where the pin is located is known as object distance U. Object distance, which is U. Altogether like that, object distance. Now take note of something. Now, please take notes so they can use to confuse you. I'm just trying to bring it up. Now, we can have magnification. Magnification is simply the ratio. Magnification of any image is always what? The ratio of the image distance to an object distance. The ratio of image distance to an object distance is known as magnification, or the ratio of image height, let's take it as HI, towards object height, let's take it as HO. So magnification is what? The ratio of the image distance to an object distance and the image height to what? An object height. That is that for that. Let me show you how we can solve this question without taking much of our time. I think that is the last thing about this. There is no much question under this topic. The only thing that is our Jam is thinking that they are smart, but we are smarter than Jam. Let's take a look at how we can do it for them. They said the distance between the pin O, the O, and the screen in the pin. Don't forget I said the distance between the O and the screen in a pin O camera is 10 centimeters. Now let me give you one thing. If you want to solve any question in physics, make sure that unit is what's uniform. You have a uniform unit. Since I'm giving here in centimeter, make sure that all your units should be in centimeter. You know here they give us 2 meters, convert the 2 meters to what? Centimeter. And if you like, you can leave it as what? Meter, but let's convert it to centimeter so that it will be easier for us to solve. Now, if you want to convert from meter to centimeter, just multiply by 100 because 100 centimeter make a what? Meter. So if 2 meter, we have 2 meter, that means 200 centimeter. Okay, let's continue. Here they said the distance between the O and the screen. The O and the screen, let me write out the pin O. This is the screen here. This is the O here. Distance between the O and the screen, which is my V. Let's write it as V, which is the image distance. And the image distance given to us is what? 10 centimeter. 10 centimeter. Let me write it out. Now, the second thing that is there is that, so what will be the size? When they say the size, they are talking about the size of the image of an object. The size is talking about the height of the image. Now, what will be the size of an image of the image of an object? 2 meter high. Object height HO is equals to 2 meter, which is equivalent to 200 centimeter. Don't forget I said 100 centimeter is 1 meter. So 200 centimeter equivalent to what? 2 meter. Now, which is placed symmetrically with regard to the camera and 10 meters from it. That means the object is placed at a distance of 10 meters from the camera. This is what they are trying to say. They given us V as 10 centimeter and U. So my U is equals to 10 meters, which is equivalent to what? 1000 centimeter. That is, 10 meters is 1000 centimeter. Let me write it out. 10 meter equivalent to 1000 over centimeter. That is given as our what? Image object distance. You know we have to find the size of the image, which is what? HI. We don't know. But anything I want to do on pinhole camera, know that you're only doing that using magnification. Now, according to magnification, I said magnification is image distance over object distance or image height to object height. Altogether. And we knew that my objects are, so we can say since that their ratio they are equal, I can say this nonsense sheet, take yourself away. Now V is 10 centimeter. Let me put it 10 centimeter over U is 1000 centimeter. 1000 centimeter. Now which is equal to HI. HI you don't know. Let's take it as HI and my H naught is taken as 200 centimeter. So you can cross multiply these and solve out what is there. So from here I can easily get what is simple. This time this will give rise to 1000 HI to equals to 10 times 200 should be 2000. Then my HI should be equals to 2000 over 1000, which will give rise to 2 centimeter. 2 centimeter. Now, what is this thing trying to tell me? I think I grabbed something important here. Now, my image height, which is the size of the image formulated, Can you see the way it is highly or simple? Jam is going to give you something that you can solve within what? 3 seconds. That you're going to produce solution within what? 3 seconds. Anything that you'll be solving more than 3 seconds, don't expect that in what? In jam. Now, my answer to that is 2 centimeters. Thank you for watching this interesting video. Don't forget to what? Click on the like button. Before you go, drop a comment for me. If it's just only, sorry Serena, I love you what? Your smile, I'm okay with that. Also Serena, I'm okay with the explanation. Thank you so much. Just drop a comment and don't forget, share the video with your friends. Thank you, see you in the next video. Thank you.